That's going to be a challenge to pause it, but we'll deal with it later. So what we're going to talk about today is polar coordinates, and we're skipping 10-6. We're not going to worry about 10-6. So plot points in the polar coordinate system, convert points from rectangular to polar, and vice versa, and convert equations from rectangular to polar. So we've been representing graphs of equations as a collection of points x, y in a rectangular plane. Because if we think about the x, y, the coordinates are always rectangular. We have length and width of every point, over, up. Now, versus x, y, direction of the coordinate plane x, y in the selection, polar. Now, polar is going to be represented by an angle and a radius. The radius will always go first, and our angle, theta, is the counterclockwise movement from the polar kind of positive x-axis. Now, r is our directed distance from O to P, and theta is our angle. So if we look at this here, 2 comma pi over 3 is a distance, positive distance of 2, and a rotation of pi over 3 to get to this point here. So this one here, we have 3 and negative pi over 6. So a distance of 3 and negative pi over 6, as shown. Now, there's different ways that we can represent this here. Now, coincidentally, the point 3 negative pi over 6 is going to be the same as 3 comma 11 pi over 6. Well, 11 pi over 6 plus pi over 6, well, 11 plus 1 is? 12 divided by 2 is? Or 6 is 2 pi. They add together to be 2 pi, one whole circle. Because this direction is a negative angle. This direction is a... Now, this is 2 different ways that we can represent this here. So 3 comma 11 pi over 6 and 3 comma negative pi over 6. So that's 2 ways. Any questions on this here so far? Now, the 180 degrees, if we're talking about this here, this angle, well, if I subtract pi from it, or 11 pi over 6 minus, so pi would be 6 pi over 6, because that's 180 degrees, would be 5 pi over 6. So this angle here would be considered 5 pi over 6, yes? Now, we can use this angle to actually describe this same point down here. But I have to change the 3 in a way that it'll work. So what can we do? Take a random guess. What can I do to the 3? Yeah, because we can change the sign. Because this here would be a positive 3. This here is a negative 3. Which means we also have negative 3 comma. Well, I can subtract it from 2 pi, which would give me negative. There's 1 would give me pi, 6. And then I would need 6, so negative. It would be negative 7 pi over 6, because we would take pi, 5 pi over 6, and subtract 2 pi from it. Because these two should add together to be the whole. So 2 pi minus 5 pi over 6 should give me the rotation this way, and then we flip it back over. So, for instance, the coordinates r comma theta and r comma theta plus 2 pi represents the same point as illustrated here. So as we see, we can keep going around and still get the same point. We're just going around in a circle. Because r is a directed distance directed, it actually gives us a direction, not a length. The coordinate r comma theta and negative r plus theta comma theta plus pi can be represented in the same point. So we can actually have 4 different ways to represent the same point in polar coordinates. Questions on this here? So in general, the point r comma theta can be represented as r comma theta plus or minus 2n pi, because we can keep going around. Or r comma theta can be represented as negative r comma theta plus 2n plus 1 pi, because we have to add pi to it to get to the other side, and then we can do rotations of it. Because to get from this side over here, if we're continuing on in this direction, we have to add pi to it. So really we're saying theta plus or minus 2n pi plus pi n, because we're talking about, or plus pi, come on, plus pi. Well, we can factor the pi out, which would just be 2n plus 1 times pi. So it's just representing that movement of 180 degrees. Does that kind of make sense? Yes? Got it for the most part? So really when we look at any point, so if we said we had 2 comma pi over 4, well, we could also have 2 comma, well, we could do pi over 4 minus 2 pi. Which would be negative 3 and 4 is 7 pi over 4. That's another way to represent it. Now, we could have negative 2 comma, well, we would need to add, because this here is in the first quadrant, so we need to add in the third. So we'd add pi, which would be 5 pi over 4. We can go this direction, so subtract it from 2 pi, which would be negative 3 pi over 4. So this here are the 4 basic ones that we can use. Others are just re-representing these by adding 2 pi to one of these here. We can keep adding 2 pi or subtracting 2 pi and getting multiple representations, but these are the kind of the 4 unique, quote unquote, unique ones, where we're keeping theta between 0 and 2 pi. Well, not 0 and 2 pi, kind of, it's more like negative 2 pi is less than or equal to theta is less than or equal to 2 pi. So we're keeping it in 2 rotations, 1 positive, 1 negative of the circle. Questions on this here? Coordinate conversions. So if we looked at this here and we wanted to really convert this from polar to rectangular and rectangular to polar, we're going to have to talk about it in terms of r and theta. Now r, as you most likely can guess, is going to be dealing with distance, and theta is going to be sine and cosine. So it works out, if we're going to polar to rectangular, x is equal to r cosine of theta, and y is equal to r. So if we're going from polar to rectangular, we're using this here. If we're going from rectangular to polar, tangent is equal to y over x. I'm thinking of cotangent. And r is equal to the square root, square root of x squared plus y squared. Really, Pythagorean theorem. because r is going to be our hypotenuse of a triangle. So we can say r squared is equal to x squared plus y squared, or really r is equal to the square root of x squared plus y squared. And the sign for it is really going to depend on what coordinate we're in. Most likely we're going to keep it positive, but if we want to get the negative, it's just changing the angle. Does that make sense? It's going back to, well, if we have it down here and we want it up. So if we have it down here, but we want it up here, then we would say that this is r and this over here is negative r. But most likely we're going to be just hitting our positive r values. The only time we'd really get negative r is if we're trying to find different ways to write the same point. Does that make sense? So convert square root of 3 comma pi over 6 to rectangular coordinates. Well, we said x, so this is where we have our x and, because x is r cosine of our angle, and y is r sine of our, well, pi over 6, 0, pi over 6, pi over 4, pi over 3. So this here would be, so we can type it in. It's going to be in radians because we have pi over 6 for x. So our rectangular coordinate is going to be 3/2 comma square root 3 over 2. That's all I have to do to convert from polar to rectangular. Boom. Boom. 3/2. Get this, which is that, which gives me this. So it's this point right here. And that's it. That's all we have to do when we're converting from polar to rectangular. Plug in r and theta, simplify. Questions on this here? Now, if we're going the other direction, we're just plugging in for y, x, and r. Luckily, this is as close as I can get to a blank screen in PowerPoint. So if we said the point 4, 7, well, if I want the angle, well, tangent theta of 7/4, we can take tangent inverse and give me my ugly decimal. And we'll leave it as this here. Most of the ones in the book, especially the ones on your assignment, aren't going to be ugly decimals. They're ugly decimals because I just picked one out at random. 1.057. No, 1. And that's our angle. Now, if we want our r value, well, r is equal to the square root of 7 squared plus 4 squared. Yep. And that'd be polar. That's all we have to do to convert from one to the other. That's it. Questions on this here? Okay. Now we talk about it with equations. Really, we're replacing x with y with r sine and r cosine. And we really want to finish it up with r being by itself. So r equals 2. What we can do is we can convert back into these overall equations. So here, so the graph of r equals 2 is just a circle straight at 2 with the radius of this here. So you can confirm this by converting it into r xy. So r is equal to 2, r squared is equal to 2 squared. Okay, let me actually write that out so it actually makes sense. Now, given this here, for our rectangular to polar, we said that r squared is equal to x squared plus y squared. Now, we don't have any sine or cosine in this, do we? So we're just saying that r is 2, so r squared would be and that's it. Because really, we have it in x and y, we don't actually have an angle that's changing anything. So this is actually our equation. So we replace what we have. Since we have r squared, we plug it in, we get 4. If we have cosine and sine, then we're going to have to plug those in accordingly. Theta is equal to pi over 3. So really what that's telling us is on the graph, we're actually just going to have a straight line where angle of rotation is pi over 3. It's just any point along that line. Now, what we do know is that tangent of theta is equal to y over x. So y is equal to tangent of theta x. Well, you're probably looking at this, why did now we all of a sudden have tangent in it? Well, our actual angle for letter B is pi over 3. So what is tangent of pi over 3? Huh? Then square root of 3x would be our equation. So that would be it, converting. So this here is the second one, the graph of where theta is equal to pi over 3. We just have that straight line. Consists of all points on the line that makes an angle of pi over 3 with the positive polar x-axis. So pi over 3 here, and this is really pi over 3 with a reference angle to the x-axis. To convert this, just like we did, we use tangent, and we get that y is equal to the square root of 3x. And that would be the equation that represents this line in rectangular coordinates. Questions on this here? We're good with this here? Now secant is equal to, so the polar coordinate r equals secant theta is the same as r cosine of theta is equal to 1. Okay, let's break this down a little bit. R is equal to, well, 1 over cosine of theta. Because secant is 1 over cosine. So we can multiply both sides by cosine. Well, those would simplify to 1, and we get r cosine of theta. Yes? What is r cosine of theta for us when we talked about polar to rectangular? X. So really, I can replace all of this here with, and get x equals 1. And that's our equation. Questions on this here? Okay. Actually, we can do that there. All right. Now we can look at other equations, like let's say, let me actually grab the book. Because I think, and I feel like y'all converting, because I'll have some of the problems converting from polar to rectangular, rectangular to polar. I feel like y'all are good there. Now the questions that you're probably going to come up with are converting each rectangular equation to polar, and then we'll have some converting polar to rectangular, converting between the two. So, x squared plus y squared equals 9. Now this one here, there's multiple ways that we can go about it. Because I could start off with saying, well, right, and we can't just, it would be the square root of x plus y equals 3, or really we're saying r is It's actually the equation. Now, say we didn't do it that way. Well, here, actually that's about the only way really to look at it, because we're really going off the fact that r squared is equal to x squared plus y squared. Because if we're wanting to do it any other way, we'd need to get x and y by itself, so then I can actually go about using tangent of theta. And most all of these are actually going to have squares in them. Most. Because if they're talking about circles, we're going to do it that way there. Actually, I take that back. Sorry. There is another way we can go about it, and we wouldn't use, because I kept trying to use rectangular to polar to try to get this to work. Well, we'd really use polar, because polar to rectangular, because we're talking about x and r here. Because if I want to go to polar, well, x is r cosine of theta squared plus r sine of theta squared is equal to 9. Now here, r cosine squared, well, that'd be r squared cosine squared of theta plus r squared sine squared of theta is equal to, well, I can factor out the r squared, cosine squared of theta plus sine squared of theta equals 9, yes? Pythagorean theorem, or our Pythagorean identity with this here, cosine squared plus sine squared is always equal to 1. If r squared is equal to 9, or really r is equal to 3. And that's our equation. So that's the other way we can do it. X is equal to y. Well, x is r cosine of theta is equal to r sine of theta. I need them on the same side, because really, in our overall equation, what we're trying to get is r equals something. We need this as r by itself. So I move it over to the same side, which shows me I have r times cosine of theta minus sine of theta is equal to make sure I did this right. No, I don't think they like that, because it's a little bit different, because it is a straight line. Because the way I did before worked, because rectangular to polar, really it's going to want us to use tangent of theta equals y over x, and r is equal to the square root of x squared plus y squared, because we're wanting to go from rectangular to polar. Now, 1 over 1, or tangent of theta is equal to 1. So tangent of theta is equal to tangent inverse of 1. And what is tangent inverse of 1? Approximate that. 5 over 4. Is actually all it's going to be. Because r really doesn't give us anything, because we don't have an r to speak of. It's weird how these work. Questions on this here so far? So really, if we just have x and y, we're doing this here. All right. 3x plus 2y equals 0. Okay. I thought I did that wrong, but I actually did that right with the last one. I was looking back at it, seeing. Okay. So we actually did that right. It just works out that the value of r for this equation, that previous one that we did, was 0, and theta ends up being pi over 4. So we don't actually have an equation, r equals, because r is 0. We can only have the angle for it. So what we actually did was correct in what we were doing. It just worked out funky. So we could look at this here. So what we did on the one previous still does work, because we can say 3 times r cosine of theta minus r is equal to 0. So we can subtract the 2. Yep. So we're going to factor out the r, which leaves us with 3. This here. And then we can divide both sides by cosine theta minus, and that actually should be our equation. Questions on this here? Negative 2 over 3 cosine of theta minus sine of theta. That is the answer. That's all we have to do for this here. We'll look at this one here. And I won't make you do some of these here. It's complicated. Xy equals 16. Well, this would be r cosine of theta times r sine of theta is equal to Yep, we'll move to the other side. And then we'd have to square root. Well, square root of 16 is plus or minus 4 times square root of cosine of theta sine of theta. would be our answer, because we can't really get sine and cosine of theta out of the radical, so we end up with this here. Yeah, I see what they're doing. Huh? No, it would actually given us the same thing. Actually, there. And what they're willing to accept is not that, but they're actually going to leave it as r squared is equal to 16. Cosine would be, and they're going to convert these over to secant and cosecant. And if we wanted to, we could use some of our other angle formulas to actually convert that into one, our double angle formulas. But that's all we would need. Questions on this here? And we could go the other direction. Kind of like the one we did already, because really r squared is, well, r squared is equal to that's it. So those aren't bad. So if we want to do something like this here, well, CSC is the same as 1 over sine, multiply both sides by sine, so we get r sine of theta is equal to 4. And really that's all we're doing, is we're manipulating these equations to get them back into a form we can rewrite. So with this equation here, we want it back into polar, so we'd actually multiply both sides by 1 plus sine, which over here 1 times r is r times sine is r theta is equal to 2. So r sine of theta is y. R is really just the square root of x squared plus, because since we don't have, we have r sine, we can change to y. But r by itself, we don't have any way to rewrite it. Besides, r is equal to the square root of x squared plus y squared. Now we would subtract, because to simplify this radical, we can square both sides, or really I'm going to move the y over. Because once I square both sides, these should cancel out, which would give us x squared plus y squared equals 4 minus 4y plus y squared. Now we want to move everything over to the same side, so we would subtract y squared, which actually would cause it to cancel out, plus 4y, because when I subtract the y squared from both sides, they would. And that would be the equation we started with to get this here. And that's it. Questions on this here? sorry, those there were more, I wanted 39 through 45 odd. And those there. So that's the entire assignment there. 5, 7, 9, 13, 39, 41, 43, 45, 59, 61, 63, 65. Fixing problems.